Hello, so in this lecture we will do a couple of examples related to basic chemistry or rate kinetics. The first one is as follows. NO reacts with ozone. So NO reacts with ozone to form NO2 and O2. NO2 plus O2, and the rate coefficient for the reaction is K at 298 Kelvin equal to 1.9 10 to power minus 14 centimeter cube per molecule per second. Now if the ozone concentration is 2.5 10 to power 11 molecules per centimeter cube and that this is fairly constant, calculate the lifetime of NO against reaction by ozone. So this is a bimolecular reaction, and if we can recall, tau is given as tau NO is equal to 1 by K concentration of ozone. So this is fairly straightforward. This is equal to 1 by K is 1.9 into 10 to the power minus 144, and ozone concentration is 2.5 into 10 to the power 11. This can be simplified as 1 divided by 4.875 into 10 to the power minus 3. So 10 to power 4 minus 14 and 10 to power 11 makes 10 to power minus 3, and 1.9 times 2.5 is 4.875. So this is basically 1000 divided by 4.875. So once we solve this, we get tau NO is approximately equal to 205 seconds. So this is the answer. Now let's look at the next question. We have a reaction A plus B gives C plus D, and the measured rate coefficient is 1.1 into 10 to power minus 10 centimeter cube per molecule per second. So this is the measured rate coefficient. The question is to calculate the collision theory rate coefficient and then determine the fraction of collisions that are reactive. We have been given the molar mass of A is 17 grams per mole, B is 33 grams per mole, and the Boltzmann constant is 1.831 into 10 to power minus 23 joules per Kelvin. The temperature is 300 Kelvin, and the radius of each molecule is 2.2 into 10 to power minus 8 centimeter. So we have to use the equation for rate coefficient as per the collision theory, and we will do it as follows. We know from the collision theory that A is given as pi d square multiplied by 8 times Boltzmann constant times temperature divided by pi times mu. to the power 1 by 2. So we will do it one by one. D is equal to RA plus RB, and we have been given RA equals to RB equals to 2 into 10 to the power minus 8 centimeter. Now if we are solving everything, better to use SI units for everything. So it will be 2 to power minus 2 into 10 to the power minus 10 meters. So pi d square will be pi times 2 into 10 to the power minus 10 plus 2 into 10 to the power minus 10 whole square. This comes out as 5.03 into 10 to the power minus 19 meter square. So now we have our pi d square. We have this term with us now. Now we must look for mu. Now we know mu is given as mass of basically one molecule of A because we have one molecule colliding with another molecule. Mass of molecule of A multiplied by mass of molecule of B divided by MA plus MB. Now what is the mass of one molecule of A? So we have been given mass of 1 mole of A. This is 17 grams. So mass of one molecule of A, this will be equal to so this 17 grams is basically 17 into 10 to power 10 to the power minus 3 kilograms. So mass of one molecule of A would be 17 into 10 to the power minus 3 divided by Avogadro number, so 6.023 into 10 to the power 23. This is Avogadro's number. So mass of one molecule of A will come out to be 2.82 2 into 10 to the power minus 26 kg per molecule. So mass of 1 mole of A would be 17 into 10 to power minus 3 kg, and we know 1 mole has Avogadro number molecules. So 1 mole is 6.023 10 to power 23 molecules. So mass of one molecule, the mass of one molecule of A would be 17 into 10 to power minus 3 divided by 6.023 into 10 to the power 23. So this comes out to be 2.82 into 10 to the power minus 26 kilograms per molecule. Similarly, we can get the molecular mass of B, and we get MB is equal to 33 into 10 to the power minus 3 divided by 6.023 into 10 to the power 23. So this comes out to be 5.48 into 10 to the power minus 26 kg per molecule. So now we have mu will be MA MB by MA plus MP. So this is equal to 2.82 into 10 to power minus 26 5.48 into 10 to power minus 26 divided by 2.82 into 10 to power minus 26 plus 5.48 into 10 to power minus 26, and mu comes out mu will come out to be 1.86 into 10 to the power minus 26 kg per molecule. So we have also mu. So now we have all the information that is needed for the calculation of A. So we have A is equal to pi d square and this is square eight kpt divided by pi mu to the power 1 by 2. So this is pi d square, we already know, or we already calculated. It is 5.03 into 10 to the power minus 19. and multiplied by 8 into Boltzmann constant 1.381 into 10 to the power minus 23 into temperature, which is 300, divided by pi. So we have 3.14 multiplied by mu. So mu is 1.86 into 10 to the power minus 26, and this fraction to the power 1 by 2. So A then comes out to be 3.8 into 10 to the power minus 16 meter cube molecule to the power minus 1 second to the power minus 1. And we can convert it to, because the measured rate coefficient is in centimeter cube, we should use 1 meter equal to 100 centimeter. So A will be equal to now 3.8 into 10 to the power minus 10 centimeter cube molecule to the power minus 1 seconds to the power minus 1. So now we can get our answer, which is the fraction. I'll just type it in a moment. So F equals to the measured rate to the theoretical value. This is equal to 0.29. So basically, if fraction 0.29 of collisions are actually reactive, that is, only 29% of the collisions are actually reactive. So this was the solution to this problem. And with this we can close this week's lecture.